This video is all about linear inequalities. The very first thing that you should know before you go to solve a linear inequality is the inequality notations that you use. The first one I want to look at is the greater than. So when we have something like x is greater than 5, let's look at that first on a graph. So here's my graph, my number line. And let's say this is 0, so here's 5, about right here. If we have x is greater than 5, I like to use an open circle. The reason I use circles as opposed to parentheses or brackets is when you get to harder inequalities, you may not know the direction the inequality is going yet. So circles and open and closed circles are a great use for that. So I have x is greater than 5 here. And notice one thing, that the alligator is opening towards the bigger number. So that means the greater than, x is greater than the smaller number 5. So greater than 5 means all the numbers bigger than 5. So on a graph that would look like that. All the numbers bigger than 5. So that is how you represent an inequality as a graph. The other notation that we have for an inequality is interval notation. So with interval notation, after you have the graph, the number line, you read the number line from left to right. So I have nothing until I get to right here. Okay, and then what we end up with is we start at 5. Because you cannot be equal to 5, we have a parenthesis. Then we start at 5, and the last number, or it goes on forever in the greater than direction, so it will go to infinity. So that is the interval notation for the graph. The next one I want to look at is greater than or equal to. So the difference between greater than is just an alligator mouth, a greater than symbol, an inequality symbol. Greater than or equal to is the same symbol, but there will be a line underneath, which if you look at just the bottom part of this, there's an equal sign, and then the top part is the greater than sign. So if I were to graph this, it would be pretty much the same graph. So I have my 5. The only difference is, instead of an open circle where you cannot be equal to 5, we have a closed circle, which means you can be equal to 5. And then we're still all the values greater than 5. Okay. Now with the interval notation, instead of having a parenthesis because you can't be equal to, we're starting at 5 again, but then we are going all the way to infinity. All right, so the difference between greater than and greater than or equal to is the open circle versus a closed circle and a parenthesis versus a bracket. Let's look at the less than. X is less than 5. I tried to pick 5 on each of these just so that we could see the similarities between each of them and the differences. So if x is less than 5, less than is a inequality symbol that is facing the right direction. We have 5 as our value. We cannot be equal to 5, so it will be an open circle, and we have the values less than 5. As interval notation, we start at infinity, and whenever you include infinity in your interval notation, it's always a parenthesis, because you can't actually be equal to infinity. So you have infinity, negative infinity, because you're going the negative direction. So we've got negative infinity all the way, and then you stop at 5. Think to yourself, is it a parenthesis or a bracket? It is a parenthesis because you cannot be equal to. All right, the last one here is less than or equal to. So we have here x is less than or equal to 5. It's the same thing as x is less than 5, except for there's an equal sign. So we can be equal to 5, and is the values less than 5. So this would be the graph, how to graphically represent a less than or equal to. As interval notation, we've got negative infinity all the way to 5, and then we stop at 5. But instead of a parenthesis where we can't be equal to, we are a bracket where we can be equal to. So that is a representation of all of the different symbols and notations that you will see with linear inequalities. Let's look at how we would solve linear inequalities. To solve a linear inequality, you follow the exact same steps as a linear equation with one exception. The only difference between a linear equation and a linear inequality is that when you divide or multiply by a negative, the direction of the linear inequality sign must be flipped. Let's look at why that must happen. So let's say I have negative x is less than 5. And I want to solve this inequality. The rule says that if you were to divide both sides by -1 to get rid of that negative, the inequality direction must be switched. So then I would end up with x is greater than -5. Now, if you think of this as not using multiplication or division, but let's say I wanted to add the x over so that it's not negative anymore. I would have 0 is less than 5 plus x, and I need to get rid of that 5. What you end up with is -5 is less than x. So these two equations are actually the same. They're just switched around, but if you were to flip this whole equation on the right side here, you would end up with x is greater than -5. So instead of adding the x over and subtracting the right side over, whatever it is, we just flip the inequality sign, and it makes the process a little bit easier. Let's look at some examples of actually solving linear equations. All right, this first inequality says 6x minus 10 is less than or equal to 8. So the first thing we would do here is we want to add the 10 over, just like in a regular equation. So then we end up with 6x is less than or equal to 18. Now, because x is being multiplied by 6, I am going to divide both sides by 6. You do not flip the sign when you multiply or divide by a positive number, only when you multiply and divide by a negative number. So then you end up with x is less than or equal to 3. So that is the inequality solved. But you always want to write your final answer as interval notation. You don't want to just leave it as a solved inequality. So here I have x is less than or equal to 3. So here's 3. We can be equal to 3, so we're going to close the circle, and we're going to be the values less than or equal to 3. So our inequality then would be -infinity to 3. And then a bracket because we can be equal to that value, 3. All right, there is our inequality solved for. Let's take a look at the next one because it is a little bit harder. Okay, the first thing I would do is I would subtract the 7 from both sides. And we end up with -3x is less than -2. Notice that I subtracted 7, so I don't flip the sign here because it's just adding or subtracting a negative number. Okay, now I want to get rid of this times -3 on the x, so I'm just going to divide both sides by -3. However, when you divide by a negative, you have to flip the direction of the sign. And so you end up with x is greater than -2 over -3, which is 2/3. All right, so as a graph on that, then we have here 2/3, and we cannot be equal to 2/3 because there's no equal sign on the bottom of that. So it's just x is greater than 2/3. And as interval notation, we're starting at 2/3, and we will go to infinity. And there's our interval notation of our final answer. That is how we solve linear inequalities. The biggest thing to watch out for on these is when you have a multiplying or dividing by a negative, you flip the sign. And then also with your open circles versus closed circles and parentheses versus brackets. Make sure you know that less than and equal to and greater than and equal to are closed circles. Less than or greater than are open circles.